Good morning, friends. Welcome back to the class. I hope you all are safe at home and healthy too. So, in session number 7 in chapter derivatives, now we are going to understand today the parametric form of the functions. Now, first try to understand what is meant by parametric form. If it is a parametric form, then how to do the derivative of that function to get dy by dx. Now, just look at this example which is already written. See, x is a function like it is defined as x is sine square t and y is equal to cos square t. Yeah, you may also write in place of t to understand better theta. So you will be very comfortable to speak now. X is equal to sine square theta and y is equal to cos square theta. So if you observe the main variables x and y, they are not directly connected. X is a function of theta, y is also a function of theta. Hence, x and y are the function of the same variable. Hence, the common variable, right, is called a parameter. And the form of the expression, form of the equations is called parametric form of the equations. So, if any two variables are connected through the third variable, then the form of the equation is called parametric form of equation. Here x and y are expressed in terms of theta, then theta is called parameter. Similarly, in the second example, x is equal to 2at where a is a constant, t is a variable, and y is equal to bt square, b is a constant, t is a variable. Here x and y both are expressed in terms of theta, in terms of t, hence t is called parameter. T is called parameter. So what does mean by parameter here? Here the common variable through which you can relate x and y. You can relate x and y through this variable simply by using substitution method. Now see, how I can eliminate this third, that is a parameter, right, from these two equations to get the relation between x and y. Now I am taking one example here. X is equal to sine square theta I am having, and y equal to cos square theta. Now I can use sine square theta identity as 1 minus cos square theta and y is as it is. Now I can replace this cos square theta with y. Hence I got the equation like y is equal to 1 minus x. So now I was able to eliminate the parameter, that is a common variable, right, through which I can relate x and y. So x and y can be related by eliminating the common variable, that is a third variable that we called as parameter. Once you eliminate that parameter, now you got a simple equation in terms of x and y. Then you can go for the derivative process to get dy by dx. So this is, if you do the derivative of this function, then dy by dx is equal to, derivative of 1 is 0 and derivative of x is 1. So your answer is minus 1 over. Derivative of this function is minus 1. So this is one of the way to get dy by dx simply by eliminating the third parameter, that is a common variable through which x and y can be related, right? So that can be, the parameter can be eliminated by doing a substitution method. Now, the question is, if the condition mentioned is without eliminating the parameter, find dy by dx. So, how can we do get the dy by dx without eliminating the parameter? That first we are going to understand in parallel. So, I am taking the same question here again. So first I will do the derivative of this function over here with respect to theta, because x is a function of theta, y is also a function of theta, then I am doing the derivative with respect to theta. So I am writing here differentiate with respect to theta. So ultimately dx by d theta is equal to, right, d by d theta of sine square theta. Now simply simplify the first part, right? It is in the form of x square. So x square derivative is 2x, and then apply the chain rule to get the next part. So simply here dx by d theta is equal to 2x, means 2 sine theta, into the derivative of sine theta in the next step. So 2 sine theta into sine theta derivative is cos theta. You may write it as simplified form as sine 2 theta. This expression is reduced to a simplest form sine 2 theta. This is the half part done. Now the next part in a similar manner. Y is also a function of theta. Hence I am doing the derivative of this entire equation with respect to theta only. So ultimately dy by d theta will give, I am directly writing the answer over here, that is 2 cos theta into derivative of cos theta, which will finally give minus cos derivative minus sine theta. So minus sine theta. Hence the total is reduced to minus sine 2 theta. So now I separately got dx by d theta and dy by d theta. To get dy by dx here by chain rule only, I can write it as dy by d theta by dx by d theta. Means simply divide the dy by d theta answer with dx by d theta to get dy by dx. This is the formula, you can say, to get dy by dx. It obtained from chain rule again. So dy by d theta answer is sine of minus sine 2 theta upon dx by d theta is sine 2 theta. Completely get cancelled. So minus 1 is the answer. See, you can see the answers are same whether you are solving, first by eliminating the common parameter first, simplify the expression to get the relation between x and y, and then go for derivative. This is one of the technique. Second technique, without eliminating the parameter. It means first we'll do the derivative with the respective theta separately, both the ways, dx by d theta and dy by d theta. Then to get dy by dx, we have to divide the dy by d theta by dx by d theta. To get the dy by dx will give the same answer. So hence what you understood from this discussion over here is, if the expression in the form of parametric form means again x and y, the variables are connected, are expressible in the common variable through a common variable, right? So in that case you have two options to get dy by dx. One is by eliminating the parameter first and then go for derivative. Second, without eliminating the parameter, also you are able to get dy by dx. Now it depends on the question, or it depends on the examiner. If he specifies that without eliminating the parameter find dy by dx, then you are bound to do in this way only. You cannot prefer this way. So if it is nothing mentioned in the question, so you have a two choices in front of you, whether you want to go with this method or that method, right? So you need to practice. first without eliminating the parameter, because in our exercise 5.6 they have mentioned that from question number 1 to 10, without eliminating the parameter, find dy by dx. Means second method is being mentioned in the textbook. That's why we are trying to solve the questions 1 to 10, right, without eliminating the parameter through the second method. Wherever it is the condition is not mentioned, then you have a choice to go for first or second, okay, according to your convenience and according to the level of question. So now let's have few questions we are going to discuss without eliminating the parameter first, okay. Yeah, just I'm keeping this here as it is so that you can easily understand which method we are following. Okay, so here t is called a parameter. Now I am taking few questions from the textbook here. See, exercise 5.6 from the NCERT. Find dy by dx. That to which method they are asking without eliminating the parameter. So first I am taking the question which is easiest one. I am taking 2at square and comma y is equal to a t to the power of 4, where a and b, c are called constants over here. Now without eliminating means directly you will go with the derivative first and then we'll get dy by dx. So here x and y are expressible in terms of t. X is a function of t, y is a function of t, hence we are going to do the derivative with respect to t. So first we have to write differentiate with respect to t. Hence now what you will say, dx by dt is equal to, since 2a is a constant, we are keeping outside. Derivative of t square is 2t. Hence, total answer would be 480. Now, we are coming to this part. dy by dt is equal to, since a is a constant, keeping outside, derivative of t power 4 is 4t cube. So, final answer is 4at cube. So this is result number 1 and this is result number 2. Now to get dy by dx, simply we can divide dy by dt answer with dx by dt answer. So dy by dt means 4at cube by 4at. So 4a get cancelled, 1t is get cancelled, you are left with t square. So answer is dy by dx, answer is t square. So no need to get surprised that the answer is in terms of t, that is in terms of the parameter. Sometimes you are getting the answer in terms of parameter, that is common variable, and sometimes not. It depending on the question. So this is the way you need to solve the question. Separately dx by dt and dy by dt, and then get dy by dx in this manner. This is the simplest manner. So which method we are using? Without eliminating the parameter as it is mentioned in the textbook itself. Then I am taking the next one. Next question. Yeah. The next question I am taking here, question number 3 here. x is equal to sine t and y is equal to cos 2t. Again, you can say here x is a function of t, y is a function of t, and t is called the parameter. Now, what we are going to do then? We have going to differentiate with respect to t, because t is a parameter. Hence, now again dx by dt is equal to cos t, and here dy by dt is equal to, it is in the form of cos x. First cos x derivative is minus sine x into derivative of 2t dash. That is chain rule we were using wherever it is a function of function, that is composition function, composite function. So dy by dt equal to minus sine 2t into derivative of 2t is 2. So this is result number 1 and this is result number 2. Now to get dy by dx as a final answer, you have to divide dy by dt with dx by dt. So minus sine 2t into 2 by cos t. So this, you could say this is an answer, but wherever the trigonometric functions are involved, where trigonometric functions are involved, if possible, make it simple to reduce the expression, to reduce the final answer. So how to get an intuition to reduce it? Simple. If you observe the angles involved, here in numerator we have 2 theta, in denominator we have theta, means we can reduce one of the t ratio to make the common angle. सो यहाँ 2t है, यहाँ t है, तो हमें किसी एक ट्रिग्नोमेट्रिक रेशियो को हम फॉर्मूलास यूज करके सिंप्लीफाई करके सिंगल थीटा में एक्सप्रेस कर सकते हैं. So that is why I am using here sin 2 theta formula, and you know very well sin 2 theta can written as 2 sin theta into cos theta. So with the help of this identity, sin 2 theta can be written as minus sin t into cos t into 2 upon cos t. Cos t get cancelled. The final answer is minus 4 sin t. This is your final answer. So wherever the angles are not identical in the entire expression, make the angles identical by using some formulas of trigonometry. Correct? So this is a technique you required in the parametric equation, parametric form of derivatives, right? So this where you need a trigonometric identities where it will simplify your answer, and this is the only area you need a lot of practice. I'll tell you the few questions where you require a lot of technique to simplify it. Chaliye, let's have a discussion over critical sums where you will face the simplification problems. Now see, the important sum, basically the question number 7, it's most important. Even question number 8 and question number 11, I would say question number 7 I am writing over here, question number 7, question number 8, question number 11, where you required tricky solutions or trigonometric identities very smartly to make the question simple. Apart from this, I will take some miscellaneous questions. Example number 48. I would like to take. Okay, so let's write the question first. What is question number 7 from the exercise 5.6? Yeah, question is like x is equal to sine cube t by under root of cos 2t and y equal to cos cube t upon under root of cos 2t. Now, if we observe x is a function of t and y is also a function of t, hence this form of equation is called parametric form with the parameter t. Hence, we need to do the derivative of both the equations with the respective t. So, I am doing the differentiate with respect to t because t is a parameter. Now, hence, I can say dx by dt. Simply apply the u by v rule. U by v rule. And that is called quotient rule. And what is that? U by v rule. You know, the derivative of u by that is quotient rule is equal to u dash into v minus v dash into u by v square. So by using this quotient rule, this is u entire numerator and this is v. So if you square the denominator, square root get cancelled, you will be left with cos 2t. Now go with the derivative u dash. U dash means derivative of this sine cube theta in the form of x cube. X cube derivative is 3x square. So we are going to use the chain rule to do the derivative of this function. So directly I am writing here 3 sine square theta into the derivative of sine theta into v means under root of cos 2t minus then v dash means derivative of denominator. Again, if you observe this function in the form of root x derivative is 1 by 2 root x. Remember, derivative of root x is 1 by 2 root x. So hence by using this formula, I would say root cos 2t means 1 by 2 root cos 2t into derivative of cos 2t in the next step. So here sin t derivative becomes cos t and cos 2t derivative become minus sin 2t. So finally what I am going to get sin square t into cos t into under root of cos 2t minus 1 by 2 root cos 2t into cos theta derivative is minus sin 2t into derivative of 2t is 2. Don't forget the chain rule. Then this minus and minus become plus and upon 1 also you can take and upon what we have cos 2t. So you can take LCM to simplify this factor. So LCM would be 2 into cos 2 into under root cos 2t. That factor becomes in denominator after LCM. So 2 root cos 2t into cos 2t, and after LCM this will be multiplied and square root is eliminated. 2 3s are 6 sine square t into cos t into cos 2t plus what you will say 2 to get cancelled. So you can eliminate here. It would be 3 only then right, with before the LCM, and then we are left with sine 2t. So this is my result number 1. So you have to remember this answer, then I will take this answer later on. So rest will solve in the similar manner, dy by dt, right? Check. So just remember this dx by dt answer. Now we are going to take the derivative of this function. Now I am solving this part. What is that? Dy by dt. Again we have to apply quotient rule. So dy by dt equal to, first in denominator it is v square, so it becomes cos 2t, and then derivative of numerator is 3 cos square t into derivative of cos t is minus sin t. I am just doing derivative of the function by using chain rule directly into v, minus derivative of v is 1 by 2 root cos 2t into derivative of cos x is minus sin x into derivative of 2t into 2. So I have solved directly, right? I believe that you will be able to understand the chain rule, and you have done a lot of practice on chain rule. That's why wherever chain rule is involved, I am directly solving. Right. So this minus into minus becomes plus, and after now take the LCM. LCM would be under root cos 2t, and that LCM becomes in denominator. So finally, what we are going to get as dy by dt, see, cos 2t is there already, so under root cos 2t will come in denominator, and this will be multiplied and square root is get cancelled, minus 3 cos square t into sin t, right, into cos 2t plus sin 2t. That's it. So this is the result number 2 I got as dy by dt, and this was dx by dt. So I have separately solved dy by dt and dx by dt. Now to get dy by dx, just I have to divide this dy by dt answer with dx by dt answer. That's it. So now that is only I am going to do here. Yeah. So if I divide this dy by dt answer with dx by dt answer, so denominator get cancelled because of the same factor. So what I am left with, dy by dx is simply minus 3 cos square t into sin t into cos 2t plus sin 2t upon 3 sin square t into cos t into cos 2t plus sin 2t, and this is possible dividing the second equation by first equation. So here what we got, dy by dx, but again the question, the answer involving the trigonometric ratios, then you have to observe whether the all the angles are of identical or not. If you observe the angle T, T and 2T, so there is a possibility to get the simplified answer. So hence you have to use an identities over here to simplify more. So first I would try to reduce the sine 2t, that is by using sine 2 theta formula, that is 2 sine t and cos t. See, Just for your reference, I am writing the formula. Sine 2t is equal to 2 sine t into cos t. And cos 2t can written as in terms of cos 2 cos square t minus 1, in terms of sine 1 minus 2 sine square t, nothing else. So first I would try to write, right, I will try to reduce it. Simply say what I would say here, minus, yeah, 3 cos square t into sine t into cos. I'm not disturbing cos, I'm just writing this sine 2t as 2 sine t and cos t, so that I can at least reduce some factors first and then I will go for the next change if required. Cos t cos 2t plus 2 sine t into cos t. So after writing this, I will be able to take sine t cos t, sine t cos t as a common factor here also, here also. So I would take first sine t into cos t as a common factor. It reduced to minus 3 cos t into cos 2t plus 2 upon sine t into cos t. So 3 sine t into cos 2t plus 2. So common factors get cancelled. Now the expression is reduced to somehow, right? But still we are having a different angles. Here t is there and here 2t is there. Again now I am going to reduce cos 2t, right, with the formulas either in terms of cos or in terms of sine. So purposely here, just look at this step, what I am going to do. In the numerator, I am having cos function. That's why I am converting cos 2t in terms of cos. In denominator, I am having sine function. Purposely, I am converting this in terms of sine. So, in the next step, what you will observe here, if I do that way, minus 3 cos t into cos 2t, I am writing in terms of cos square t minus 1 plus 2 upon 3 sin t into 1 minus 2 sine square t plus 2. So what is the purpose? To write cos 2t formulas, one in terms of cos, other in terms of sine. That intuition you must get, right? If I do the multiplication of this factor with minus 3 cos t, or I can also say, yeah, आप चेक करिए एक बार यहाँ से ऐसे करने पर क्या फायदा होगा, right? So minus what we call it as 6 cos cube t minus into minus plus 3 cos t plus 2, right, upon, if I multiply here, what you will get, 3 sin t minus 6 sin cube t, right? Yeah. Plus 2, like this. So I think I have not done any mistake in the sum. If it is there, it's a catch to be found. चाहिए जो भी है. So now if you observe something, it reduced to some formula like what we called it as 3 sin t minus 4 sin cube t. I just wanted to reduce into sin 3 theta formula, but I was not able to get. Anyhow, If there is any simplification required or any mistake I have committed during the simplification, just go through yourself. You will definitely get that catch, right, where I have committed the mistake. But if it is not, you can see the answer in terms of pure t, that is what, single theta. Okay, I am stopping over here only, so rest you can reduce it to get the answer. Okay, I have missed something out. So just resolve this question, and now just to get the correction in the solution wherever it is being committed by mistake. So next, move to the next question. But the way of simplification is the same, methodology is same. If there is any calculation error is occurred, please rectify it and you will get the simplest form. It reduced to cos 3t formula and it is reduced to sin 3t formula. Answer is given as minus cot 3t. I'll tell you the answer of this question is minus cot 3t. Okay, so you have to get this answer after simplification of this question. Just try to solve it. Yeah. Now doing the next question. Here, question number 8. Question number 8. X is equal to a times of cos t plus log of t by 2, where y is equal to its simple function a sine t. Again, without eliminating the parameter, you need to solve dy by dx. Again, the same way, x is a function of t, y is a function of t. Hence, we are going to do the derivative with respect to t. So, hence, I can write dx by dt by keeping a constant outside. Derivative of cos t is minus sin t. Derivative of log x is 1 by x into derivative of t by 2. T by 2 derivative means half is a constant and derivative of t is 1. So hence it reduced to what? A into by k, taking this 2, r2 get cancelled, minus sin t plus half 1 by t. So this is the answer. You may also take the LCM over here to get a simplified one. By taking LCM, you would say minus t times into sine t plus 1, this over, and dy by dt, this is for this, equal to, simply it is a cos t. Now you know how to get, this is dy by dx. So this is dy by dt by dx by dt. Hence a cos t is divided by a times of minus t sine t plus 1 by t. And a get cancelled, t will go in numerator. So it reduced to what? T cos t upon, you may also write it as 1 minus t into sine t. Yeah, 1 by x and rest is t by 2. T by 2 means 1 by 2 with 1. Fine. Yeah. So you may leave the answer over here. Otherwise, you may also simplify further if you want to, right? This is a final answer you could say, right? Because the angles are in the same t ratio, or we can say having the same angle like t, right? Otherwise, you want to simplify more and more, you can go, because we don't have any target to simplify it. So every step is an answer, but somehow if you require, so you need to do. Fine. So now let's have another question. Here, question number 11 I am taking. Question number 11 I am taking as the last question of today's class, right? So x is equal to a, that is under root of a power sine inverse t, and y equal to under root of a to the power of cos inverse t. And in this question, they have mentioned the target. Prove that dy by dx is equal to minus y by x. See, this is a question. Now, just here for this question, they have not mentioned that we do the derivative of this function without eliminating the parameters. In this case, we are having both the options. Either you eliminate the parameter first, then go for derivative. That is one way. Second is what? Without eliminating the parameter. So in some questions, right, by eliminating the parameter in the beginning would be suggestive method. So in this question, this would be the suggestive one. So we are going to use this method. First, I will eliminate the parameter. And what is the parameter we have? T is a parameter because x is a function of t, y is also a function of t, and t is called the parameter. So first, I will try to eliminate the parameter either by elimination method or by substitution method. So first I will do the squaring on both the sides. There are several ways to simplify because now it becomes the open-ended question. So the student may think in a rational way in many ways to get dy by dx. So I think the method which I am going to introduce it with the easiest one. See, if I do the squaring on both the sides, x square will become what? A to the power of sine power sine inverse t, and y square is equal to a to the power of cos inverse t. This is result number 1, this is result number 2. And then I am doing the multiplication of both the result. If I do the multiplication of both the result means left is multiplied by left, right is multiplied by right. That is what? X square into y square value is given by a to the power of sine inverse t into a to the power of cos inverse t. So if we do in this way, x square into y square will give a to the power of, their powers will be added by the rule of exponent, plus cos inverse t. So sine inverse t plus cos inverse t will give pi by 2, as it is the identity of inverse trigonometric ratios in their common domain. So hence this reduced to what? Pi by 2. Hence I would say x square into y square equal to a to the power of pi by 2. Hence this completely becomes a constant. A is already constant, pi by 2 is one of the constant, hence the total one becomes a constant whose derivative becomes 0 in the next step when we go for it. So now start the derivative. First I have eliminated the parameter. You can see here in the result There is no t, there is no parameter. So now I can go for simple derivative process where we can apply the product rule over here. So x square into derivative of y square plus y square into derivative of x square, and this becomes 0. So in the next step, what I am going to get, x square into derivative of y square is 2y into y dash, because y का derivative y dash होगा, then y square into derivative of x square is what, 2x equal to 0. Now you can say 2 is a common factor, that is, you can take it as common factor and that will go in denominator. And then what we left with, you can also write like y dash equal to minus x into y square by x square into y, just by shifting the terms smartly. So y dash equal to x get cancelled, y get cancelled, answer is minus 5 by x. So now you got the answer here, dy by dx is minus 5 by x. So this is one of the technique only. So you may go with any of the technique. You may take log on both the side to do the derivative of first and second and then go for dy by dx. So it's up to you. When it is not mentioned the method by which you have to solve to get dy by dx, right? So we have multiple options to do the same question. I thought this is the simplest way to do get the dy by dx. Okay, so in this manner, you may solve the entire exercise, that is 5.6. Apart from this, there are three questions in miscellaneous exercise, including example number 48. Please go through it, the exercise thoroughly and solve it perfectly, and each and every question. Don't try to skip a single question from NCRT, though it is an example, solved example or exercise question. So thank you for watching the video. Keep watching, keep learning and keep growing. Thank you once again. Take care. Bye bye. We'll meet soon in session 8.